Welcome. Tonight there is nowhere you need to be and nothing you must do. Let your shoulders ease down, let your breath find a slower rhythm, and let the room grow soft around you. Tonight we drift far past the Earth, out to a golden telescope that keeps watch over the oldest light there is. This is the Circadian Institute, where each night we travel somewhere vast and unhurried, and let the slow rhythms of the cosmos carry a tired mind toward sleep. Tonight our destination is the James Webb Space Telescope, the great golden eye that floats 1.5 million kilometers beyond the Earth. If this voice helps you rest, subscribing keeps these long, calm nights within reach. There is nothing to learn tonight, and nothing you need to hold on to. This is a slow drift through the story of a telescope and the ancient light it gathers, told as a place to rest. You only have to listen and let the deep calm of space settle over you. We will move without hurry tonight, from the long dream of building such an eye, through its folded journey into the dark, its first faint views of the earliest galaxies, the birthplaces of stars, the far worlds that circle other suns, and the long watch it keeps while the world below it sleeps. Nothing to remember, only the slow turning of the sky. For all of history, people looked up at the night sky with the eyes they were born with, and saw only the brightest, nearest things. The faintest light, the oldest light, the light from the very edge of time, fell on the earth unseen, far too dim and far too red for any human eye to catch. So we began to build better eyes, glass lenses, then curved mirrors, then great telescopes on cold mountaintops, each one gathering a little more light than the eye alone, each one carrying our sight a little further out into the dark. But the Earth's air, the very air that keeps us alive, blurs and smudges the light of the stars. It is why they seem to twinkle. To see the universe truly sharp and still, an eye would have to rise above the air entirely, out into the silence of space. And there was a deeper limit still. The light of the first galaxies, born when the universe was young, has been traveling toward us for more than 13 billion years along that vast road. The light itself has been stretched and reddened until it slipped out of the colors our eyes can see. To catch that ancient reddened glow, we would need a new kind of eye, larger than any flown before, colder than almost anywhere in the universe, and tuned not to ordinary light, but to the faint warmth of heat. That eye became the James Webb Space Telescope. The light your eyes can read is only a thin sliver of all the light there is. Beyond the deep red edge of what we can see lies infrared, the light of warmth, the glow given off by anything that holds a little heat. We feel it on our skin near a fire, though we cannot see it. Almost everything in the cosmos shines in this hidden warmth. Cool clouds of gas and dust, newborn stars still wrapped in their cradles, far planets warmed by distant suns, all of them glow softly in infrared, in colors no human eye has ever held. Ordinary visible light cannot pass through thick cosmic dust. It scatters and stops, the way headlights fade in fog. But infrared light slips straight through those dark clouds, carrying the glow of whatever is hidden deep inside. So to see the things that visible telescopes miss, the cold, the distant, the deeply hidden, you must look in infrared. You must build an eye that reads heat the way ours reads color. There is a difficulty in this, though. An eye that reads heat must itself be cold, colder than its surroundings, or its own faint warmth would drown out the distant glow it is trying to catch. To see the heat of the universe, the telescope had to become one of the coldest things in it. Light is swift beyond imagining, but it is not instant. It travels about 300,000 kilometers every second, and no faster. Across a room, that delay is nothing. Across the gulfs between the stars, it becomes the whole story. When you look at the sun, you see it as it was about 8 minutes ago, for that is how long its light takes to reach us. The sun could, in theory, have changed in those minutes, and you would not yet know. Look further, and you look further back. The nearest bright star beyond the sun shows itself as it was years ago. A distant galaxy shows itself as it was millions of years ago. To gaze across space is to gaze across time itself. This is the quiet gift hidden in the slowness of light. A telescope large enough to gather light from the farthest reaches is also a kind of clock that runs backward, showing the universe not as it is now, but as it was long ago. And so, by looking far enough into the dark, this golden eye could see almost all the way back to the beginning, to the first faint galaxies that formed when the universe was young and new. The deepest looking is also the oldest remembering. Before this telescope, another rose above the air and changed how we saw the cosmos. For decades it circled close to the Earth, sending home sharp pictures of nebulae and galaxies that filled books and dreams alike. That earlier eye looked mostly in the light we can see, and it reached far. It found galaxies in patches of sky that had seemed empty, and showed that the dark between the stars was, in truth, brimming with distant light. But its mirror was modest in size, and it could not read the deep infrared, the very oldest galaxies. Their light stretched far past red, stayed just beyond its reach, like a word on the tip of the tongue that will not quite come. So a new telescope was imagined to carry the work onward, far larger, far colder, and tuned to the hidden warmth the older eye could not catch. It would not replace what came before. It would reach past it into the dark it could not enter. Together they would form a chain of sight reaching out from the earth, one looking in the colors of day, one in the warmth of the deep, each handing the work of seeing a little further to the next. A telescope like this is not built in a year, nor in 5. The idea was first sketched while the older eye had only just begun its work, and it would take some 25 years to carry that idea from a drawing into the sky. Thousands of hands across many countries shaped it, though we will picture only the work itself tonight, the mirror polished to an impossible smoothness, the thin gold laid down atom by atom, the folding shield tested again and again. It was delayed and delayed again. Each delay was a choice to be careful rather than quick, because once it left the Earth, no one could ever fly out to fix it. It had to be right the first time, in a place too far away to reach. There were hundreds of small steps that all had to unfold perfectly in space, any one of which could undo the whole. The people who built it knew this, and so they waited and tested and waited again until the careful, slow work was truly done. And then at last, after a quarter of a century of slow and careful making, the dream was folded up tight, smaller than the rocket that would carry it, and made ready to leave the world that had built it. At the heart of the telescope is a mirror 6.5 meters across, far too wide to fit in one piece inside any rocket ever built. So instead of one great disk, the mirror was made of 18 smaller pieces, each a six-sided hexagon. A hexagon is a shape the bees know well. Six-sided pieces fit together with no gaps, edge to edge, so that 18 of them could join into one smooth curve, a single great eye assembled from many. Each segment is made of beryllium, a light and steady metal that barely changes shape as it cools. In the deep chill of space, an ordinary mirror would warp and blur. This one would hold its form smooth and true in the cold. If you could stretch one of these segments out to the width of a whole country, its tallest bump and deepest dip would differ by less than the height of a blade of grass. That is how smooth it had to be to focus the faintest light. Folded for launch, the side panels of mirrors tucked inward like the wings of a resting moth. Only in space would they open and lock into a single curve, and only then would the 18 become one true eye. Let us pause here a moment and simply rest in the deep between the stars. There is no need to follow every word. The voice will go on, and you can let it blur at the edges the way the sky blurs as sleep draws near. Far above the world, the telescope drifts without a sound. There is no wind there, no weather, no day or night as we know them, only the slow fall of starlight onto a waiting golden surface. Wherever you are lying tonight, you are turning too. Carried around by the Earth as it wheels through space, you are already moving through the cosmos, gently without lifting a finger. So let yourself be carried. The sky will keep its slow turning whether you watch it or not. For now there is only your breath, the soft dark, and the far quiet glow of a telescope keeping its long watch. The mirrors gleam gold, and the gold is not for beauty alone. A thin coat of gold reflects infrared light better than almost any other surface, sending the faint warmth of distant galaxies cleanly toward the cameras instead of soaking it away. The layer is astonishingly thin, only about 100 millionths of a millimeter, a film of gold just a few hundred atoms deep. Spread across all 18 segments, the whole coat would weigh no more than a small handful of coins. Over that delicate gold lies a coat of clear glass thinner still to guard the soft metal from harm. Together they make a surface both tender and tough, ready to last for years in the cold without tarnishing or fading. Laying the gold down was slow and exacting work. The metal was turned into a fine vapor and settled atom by atom evenly across the curved glass until the whole face shone with one unbroken warmth. And so the color of the telescope is, in a sense, the color of its purpose. It shines gold because gold is what best gathers the old red light of the early universe and carries it home. A mirror this large must be aimed with impossible care. Behind each of the 18 segments sit small motors, fine enough to nudge the glass by amounts smaller than a single germ, tuning all 18 until they act as one smooth surface. When the telescope first opened its eye, those 18 mirrors each showed their own separate copy of a single star, 18 faint points where there should have been one. The slow work was to draw them together. Step by step, the motors tilted and shifted each segment, and the 18 points of light slid closer, merged, and at last became one clean, bright, steady star. The great eye had learned to focus. The shape of that aimed light carries a quiet signature. Around every bright star the telescope sees, 6 fine spikes spread out like the points of a snowflake, born from the 6-sided edges of its mirrors. Those spikes are how you can tell at a glance that an image came from this telescope and no other. They are its handwriting, written in light, around every sun it studies. To stay cold, the telescope needed shade, not a little shade, but a vast shield to hold back the heat of the sun. So it carries a sun shield as wide as a tennis court, unfurled beneath its mirror like a great silver sail. The shield is not 1 sheet, but 5, each thinner than a human hair, stacked with gaps of empty space between them. Heat that passes the first layer is turned aside by the next, and the next, until almost none remains. The sunlit side can reach the heat of boiling water and more, while the shaded side, only a few layers away, falls to more than 200 degrees below freezing. Few places hold such warmth and such cold so close together. Folding such a wide, thin thing for launch, and unfolding it again without a single tear, was among the hardest tasks of all. Thin cords and tiny pulleys had to draw each layer out and pull it tight, in the cold with no second chance. When at last all 5 layers spread wide and drew tight, the mirror above them settled into a lasting cool shadow, the still cold place from which it could finally begin to see. The whole telescope lives a double life, split by its shield. On one side face the sun, the earth, and the moon, all kept firmly behind the silver layers. On the other side, in deep shade, ride the mirror and the cameras. On the warm side sits the spacecraft's working heart, its power, its small thrusters, the dish that speaks to Earth. It can stay warm without harm, for warmth there does no damage. On the cold side, everything is hushed and frozen. The mirror rests near 230 degrees below zero, so cold that its own glow nearly vanishes, leaving room for the faint warmth of far galaxies to be heard. This careful balance, sunlight forever on one face, deep cold forever on the other, never changes as the telescope flies. The shield always points the same way, holding the cold side in its lasting shade. So the eye keeps its cool the way a traveler keeps to the shaded side of a hot road, turning a broad shield to the sun and walking always in its shadow, all the way across the sky. Behind the mirror wait the instruments, the cameras and light readers that turn gathered warmth into pictures and meaning. There are 4 of them, each built for a different part of the infrared, each holding its own kind of quiet skill. One is the main camera, the wide, gentle eye that takes the great deep images of galaxies and star clouds. Most of the pictures you may have seen of this telescope's work were caught by it. Others split the light into its many shades to read what far-off things are made of. Different materials leave their own marks in the light, so that even an unreachable world can quietly tell us its ingredients. The 4th instrument reaches into the deepest, coldest infrared of all, the realm of the oldest dust and the chilliest clouds. To work there it must be colder even than the rest, chilled by a small machine that carries away its last trace of heat. Together, the 4 instruments give the telescope not one talent, but many: to picture, to measure, to weigh the light of things almost beyond reach, and to do it all in the warmth our eyes can never see. The light from the first galaxies arrives at the mirror not in floods but in trickles, a few faint grains of light called photons drifting in after a journey of billions of years. The cameras must be able to count them almost one by one. To do this, the detectors must be still and cold and free of any stray glow. The smallest warmth, the faintest leak of light, would bury the trickle of ancient photons the way a candle is lost beside the noon sun. So the telescope stares sometimes for many hours at one small patch of sky, letting the faint light gather grain by grain until a picture slowly builds, the way a bucket fills under the gentlest of drips. The longer it looks, the more it sees. An hour shows faint galaxies, many hours show fainter ones still, and the deepest, longest looks reach the dimmest, oldest light at the very edge of what can be seen. It is a kind of listening, really, holding still in the cold and the dark, gathering the faintest whisper of light across the longest reach of time, until the whisper becomes an image. Rest here again for a while. We have built the eye in our minds, the golden mirror, the silver shield, the cold cameras waiting behind. There is nothing more to gather now but stillness. Let the details slip away if they wish. You do not need to keep them. They were only meant to give your thoughts something slow and far away to settle on, while your body grows heavier against the bed. Soon the telescope will leave the Earth, but there is no hurry for that. Out in space, time is wide and slow, and nothing waits on the clock. The launch will come when it comes. For now, breathe and let the dark hold you the way space holds the stars, loosely, kindly, with all the room in the world. There is nowhere else you need to be tonight. The telescope left the Earth on a December morning from a launch pad near the sea on the green northern coast of South America, where the rainforest meets the Atlantic and rockets rise close to the middle of the world. It rode atop a powerful and well-tried rocket, folded tight inside the smooth shell at its very top. Years of work waited there in the quiet before dawn, sealed and ready, wrapped against the coming roar. Being so near the middle of the world gave the rocket a small free push, for the Earth spins fastest there. Every bit of help mattered, because the telescope needed to reach a point far beyond the moon. The countdown fell away, second by second, in the cool sea air. There was no way to test this final step beforehand. The folding, the flight, the long journey, all of it would now have to simply happen and happen right. And then, in a slow blossom of fire and a sound that rolled across the water, the rocket lifted, lifting with it a quarter century of work and the hopes of seeing further than anyone ever had. Up it climbed through the thick low air and into the thinner blue above, the rainforest shrinking to a green carpet, the sea spreading wide and bright beneath the climbing flame. Soon the sky overhead darkened from blue to deep violet to black, and the stars came out though it was morning, for the rocket had climbed above most of the air that paints our daytime sky. The empty shell that had shielded the telescope split open and fell away, no longer needed in the airless dark. For the first time, the folded telescope met open space, riding the last of the rocket's push. Then the telescope let go of the rocket entirely, and floated free for the first time alone, turning slowly against the stars, beginning the longest part of its journey on nothing but its own quiet motion. Its first act, alone in space, was to spread a single wing of solar panels toward the sun and begin to drink in light for power. With that, it was no longer cargo. It was a living machine awake. Now began the hardest stretch of all, the slow opening of the telescope in space, a long sequence of hundreds of careful moves, each one needing to work, none of which could be undone if it went wrong. First came the great shield. A tower lifted the mirror gently away from the spacecraft body, making room for the wide silver layers to spread between them, like raising a roof before unrolling the cloth beneath. Then long arms swung outward, drawing the folded shield wide on either side, and thin cords began the slow work of pulling each of the 5 layers out flat and tight, one after another, over several days. Far away on Earth, there was nothing to do but watch the signals and wait, layer by layer, move by move. Each small success eased the next, and slowly the great silver sail took its full and lasting shape. With the shield open at last, the mirror fell into deep shade and the long cooling began. The hardest folding was behind it. Only the mirror itself remained to open. The mirror had ridden into space folded in 3, its 2 side panels turned inward to fit the rocket. Now in the cold shade of the open shield, it was time for them to swing out and lock into place. One wing turned slowly outward, swung into line with the central panels, and latched. Then the other followed, easing out across the dark until the 18 hexagons formed at last one smooth, unbroken curve. For the first time, the great eye was fully open, 6.5 meters of gold, spread wide beneath the stars, complete in shape though not yet in focus. The folding that had taken years to design was finished in a matter of days. Across the world, those who had built it let out a long breath. The most dangerous steps were done. Nothing else would need to unfold. From here on, the work would be the work of seeing. But the telescope was still flying outward, away from the Earth, toward the far quiet place where it would make its home. The unfolding was over. The long coast to its orbit went on. The telescope was bound for a special point in space, about 1.5 million kilometers from the Earth, roughly 4 times as far as the Moon on the side of our planet that faces away from the Sun. It is a place where the pull of the Sun and the pull of the Earth fall into a kind of balance, so that a telescope set there can keep pace with the Earth as it circles the Sun year after year without drifting away. From that point, the Sun, the Earth, and the Moon all lie in nearly the same direction, all on one side, all easy to hide behind a single shield. The cold side of the telescope can face the open dark forever. It does not sit exactly on that point, but circles slowly around it, tracing a wide loop that takes about half a year to complete, the way a leaf turns in a slow eddy at the edge of a stream. After about a month of coasting outward, a final brief nudge of its small thrusters eased it into that wide, slow loop. The telescope had arrived at the still, far place it would call home. Arriving was not the same as seeing. The mirror was open but not yet aimed. The cameras were cooling but not yet keen. For weeks, the telescope worked through the slow steps of bringing itself into focus. It began by staring at a single ordinary star and seeing it 18 times over, once in each segment. Then, mirror by mirror, those 18 blurred copies were nudged together until they fused into one clean point. As the focus sharpened, the background filled with surprises. Behind the single test star, in what should have been empty dark, lay faint galaxies beyond counting, already crowding into the very first sharp image. The cameras, meanwhile, kept falling colder, the deepest of them chilled by a small machine until it neared the lowest cold there is. Only then could it read the faintest, longest warmth without drowning it in its own. And then at last, after the years of building and the weeks of tuning, the great eye was ready. It turned toward the deep dark, opened fully to the oldest light, and began the work it was made for. Let us rest here at the far still point where the telescope has come to settle. The journey is over now. There is nothing ahead but the slow, calm work of looking. 1.5 million kilometers away, the Earth is only a small blue spark, easy to cover with a fingertip, though no fingers reach so far. You and everyone you have ever known live on that single small light. Out there, nothing rushes. The telescope turns slowly to face one patch of sky, then another, gathering light with no sense of hurry, hour upon hour in the cold and the calm. Let your own thoughts move that slowly now. There is nowhere further to travel tonight. You have arrived with the telescope at the quiet edge of things, and you can simply rest here in the dark. When the telescope was ready, the first full picture it shared with the world was not a planet or a single star, but a small square of deep sky chosen because it had seemed to older eyes almost empty. That square was aimed at a distant cluster of galaxies, a great crowd of them bound together by their own weight far across the cosmos. In the older, shallower views, only a faint scattering of light had shone there. But where the old eye had seen a thin sprinkle, the new eye saw a multitude. The same small square now blazed with galaxies beyond counting, near and far, bright and faint, filling every corner of the frame. Each speck of light in that picture was not a star, but a whole galaxy, a city of 100 billion suns. There were thousands of them in a single image, and each held worlds and wonders of its own. It was the deepest, sharpest view of the distant universe anyone had ever seen, gathered in less than a day. And it was only the very first picture, the opening note of a long song of seeing. Here is the part that is hard to hold in the mind. That whole crowded image with its thousands of galaxies covers only a tiny speck of the sky, about the size of a single grain of sand seen from far across a room. Hold up a grain of sand to the night sky, and the patch it hides is the patch this picture shows. Within that pinprick of darkness lay thousands of galaxies waiting to be seen. Now turn that thought around. The whole sky holds millions upon millions of such specks, and every one of them, looked at deeply enough, would brim with galaxies just the same. So the universe is not mostly empty after all. The dark between the stars is not a void but a depth, layered with galaxy behind galaxy behind galaxy, further than any single look can reach. It is a thought to grow sleepy by, that the smallest dark corner of the sky holds more worlds than there are grains of sand on a long evening beach. There is no end to it that we have ever found. Look closely at that first deep image, and you may notice something odd. Thin, curved streaks of light like smears or brushstrokes, arcing gently around the heavy cluster at the center. Those streaks are not flaws, they are whole galaxies far behind the cluster, whose light has been bent and stretched as it passed the cluster's great weight, the way a glass of water bends the view behind it. Heavy things bend the very space around them, and light, following the shape of that space, curves along with it. A massive cluster becomes a great lens in the sky, magnifying whatever lies behind. This bending is a gift to the telescope. The cluster's lens gathers and brightens the light of galaxies so distant and faint that even the great mirror could not catch them alone. So nature lends its own help. Stacked behind the telescope's mirror is a lens far larger than any we could build, a whole cluster of galaxies, quietly magnifying the deep past for us to see. Among the thousands of galaxies in the deep field, the brightest and largest are the nearest. The eye is drawn to them first, but the real treasures are the faintest specks, the ones almost lost in the deep. Those dimmest smudges are the most distant, and so the oldest. Their light has traveled so far and for so long that it shows them not as they are now, but as they were billions of years in the past. Some of them shine to us from a time when the universe was only a small fraction of its present age, young galaxies still forming, seen across almost the entire history of the cosmos. To find these ancient smudges among the crowd, the telescope reads how deeply their light has been reddened by the long journey. The redder the glow in this deep view, the older the story it tells. And so a single image becomes a kind of core sample drilled through time. The recent universe near the surface, the ancient universe far below, all caught together in one small square of deep and crowded sky. A picture shows where things are, but the telescope can do something subtler still. It can spread a beam of light out into its many shades, the way a drop of rain spreads sunlight into a bow of color. Hidden in those shades are fine, dark, and bright lines, and each line is a fingerprint. Every kind of atom and molecule leaves its own pattern in light, a signature it cannot help but write. So by reading the colors of a distant glow, the telescope can name what that far thing is made of, the gas in a galaxy, the dust in a cloud, even the air around a world too far to ever visit. It can measure how warm a thing is, how fast it moves toward us or away, and how its light has been stretched by the long road. A single beam, carefully read, becomes a small full story. This quiet reading of color is, in many ways, the telescope's deepest gift. It turns far points of light from mere specks into places, each with a makeup, a motion, and an age of its own. Let us rest a while among the galaxies. There are so many of them that no mind could ever hold them all. And there is comfort in that. You're not asked to. You may simply float here and let them shine. Each one of those faint lights is turning slowly, full of stars, perhaps full of worlds, going about its long life, whether or not anyone is watching. The universe does its work in the calm, without need of an audience. You do not have to understand them to be soothed by them. It is enough to know they are there, distant, countless and calm, filling the dark you once thought empty with a soft and endless light. Breathe, and let yourself sink a little deeper toward sleep. The galaxies will keep their slow turning, the telescope will keep its long watch, and the dark, far from empty, will hold you among the light. Run the whole story of the cosmos backward in your mind, and you reach a time before there were any stars at all. The young universe, not long after its beginning, held no points of light, only a thin, even haze spread through the dark. It was a warm fog of simple gas, mostly hydrogen, with no suns to light it and no shapes to break it. The cosmos was awake but blind, a wide gray dawn before the first true day. Through that long stretch, the cosmos slowly cooled and slowly gathered. Here and there the thin gas began to pool and clump, pulled together by its own faint weight, building toward something the universe had never held before. We call that stretch the cosmic dark ages, not dark with menace, but dark for lack of stars, a long unlit waiting while the seeds of the first suns drew slowly together in the gloom. And this is the great prize the telescope reaches for, the very first light to break that dark, the dawn of the first stars and galaxies glowing at the far edge of all we can ever see. At last, in the densest of those gathering pools, the gas grew so heavy and so hot at its heart that it caught fire in the way only a star can, and the first suns in all of history began to shine. These first stars were unlike any that came later, made only of the simplest gas, with none of the heavier stuff that seasons stars today. They grew enormous, far larger and far brighter than our own modest sun. They burned hard and fast, living only a short while before ending in great bursts, but in their brief, fierce lives they forged the first heavier elements, the carbon, the oxygen, the iron from which all later worlds would be made. Every heavier atom in your body, the iron in your blood, the calcium in your bones was first made inside stars like these or the ones that followed. The first suns began the slow seeding of the cosmos with the stuff of life. The telescope hunts for the faint, far glow of this first starlight, stretched almost beyond recognition by its long journey. To find even a trace of it would be to glimpse the very first morning of the stars. The first stars did not stay alone. They gathered with their gas into the first small galaxies, loose glowing clumps that were the seeds of the great star cities to come. The telescope has now found some of these early galaxies shining to us from astonishingly far away, from a time when the universe was only a few 100 million years old, a small fraction of its present age. The light from the most distant of them set out when the cosmos was perhaps 300 million years old, and has been traveling ever since for more than 13 billion years to land at last on the golden mirror. To see them is to look almost all the way back to the beginning. Beyond them lie only the first stars, and beyond those the long dark, and beyond that the edge of what light can ever show us. Each new record is a small step further into that dawn. With every deeper look, the telescope inches closer to the first light of all, reading the opening lines of a story 13 billion years long. When the first stars and galaxies lit up, their light did something to the fog of gas that filled the early universe. It began slowly to burn the mist away, clearing the cosmos until starlight could travel freely across it. Before that clearing, the gas was a kind of fog that scattered light and kept the young cosmos dim. After it, space became clear and open, the way a morning mist lifts off a valley to let the long view return. The clearing did not happen all at once. It opened first in bubbles around the brightest young galaxies, and those bubbles slowly grew and joined until the whole universe stood clear and ready to be seen. The telescope can study this great clearing by watching how the light of distant galaxies is dimmed or freed by the gas it passes through, reading the slow lifting of the cosmic fog across billions of years. It is, in a way, the story of the cosmos opening its eyes, the moment the universe went from a closed gray fog to the clear, deep, star-filled dark we look out into tonight. When the telescope first looked into the deep past, it found something that puzzled the people who study these things. The early galaxies were brighter and seemed more grown than anyone had thought they could be so soon. By the older guesses, galaxies so young should have been small, faint, and ragged. Instead, some shone strong and full, as though the cosmos had built its first star cities faster than the old stories allowed. This is not a problem so much as a gift. The surprise is how understanding grows. Each one tells those who study the sky that the early universe was busier and quicker than they had pictured. Perhaps the first stars were larger and brighter than thought. Perhaps the gas gathered faster. The careful work of sorting out the answers is still going on, night after quiet night, look after look. And that is how it should be. A great telescope is not built only to confirm what we expect, but to show us where we were wrong, and to open questions we did not yet know how to ask. Let us rest here at the dawn of things, where the first stars are lighting the long dark. There is something soothing in such a distance. These events are so far away in space and in time that nothing about them can trouble you tonight. All of it happened long before the Earth, before the Sun, before there was anyone to watch, and yet here you are, ages later, resting warm in the deep, with that ancient light only now arriving. You do not have to feel small beneath all this. You can feel held instead, a late and welcome part of a very long story, one of the newest lights in a cosmos that took billions of years to learn how to make you. So breathe and rest. The first light has been traveling toward this moment for 13 billion years. It can wait the few soft minutes more it takes for you to fall asleep. Stars are not born in the open dark, but inside great cold clouds of gas and dust that float between the older stars, vast dim rolling banks, some of them light years deep, where the cosmos keeps the makings of new suns. These clouds are so thick with dust that ordinary light cannot pass through them. To our usual telescopes, they look like holes in the sky, dark patches where the stars behind them are blotted out. But infrared light slips through that dust, and so the golden eye can see straight into the hidden heart of the cloud, to the warm young stars taking shape deep within, unseen by any other kind of eye. Inside, the same slow gathering that made the first stars goes on still. Knots of gas pull themselves together, growing denser and warmer at their cores until each one is ready to kindle into a star of its own. So the death of old stars scattering their dust, and the birth of new ones, gathering it again, turned together in a slow wheel. The telescope lets us watch that wheel turning deep inside the clouds where it spins. In one such cloud stand great towers of gas and dust, light years tall, rising like cliffs or tree trunks against a glow of distant stars. They have a fond old name, the Pillars of Creation. Older pictures showed them as dark, solid spires. But when the golden eye looked in infrared, the pillars turned soft and translucent, and points of new starlight shone out from within and behind them. At the tips of the pillars glow small knots of deep red, like embers at the ends of branches. Each one is a star being born, still wrapped in the gas it is gathering, just beginning to shine. The pillars themselves are slowly being worn away by the fierce light of nearby massive stars, carved like rock by a slow wind. They are towers in the act of both making stars and being unmade. They are unimaginably large. Each pillar could swallow our whole solar system many times over, and yet lit in infrared, they look tender, almost like something growing, reaching upward into the light. In another great nebula, the telescope showed what looks for all the world like a range of golden mountains beneath a deep blue sky, their peaks catching the dawn. The picture has come to be called the Cosmic Cliffs. But these are not mountains of rock. They are the edge of a huge cavity in a cloud of gas, hollowed out by the fierce light and wind of young stars blazing just above the frame. The tallest of those misty peaks rise across distances it would take light many years to cross. What looks like a quiet dawn landscape is in truth a vast wall of gas slowly boiling away into space. From the steaming tops of the cliffs, fine streamers and jets trail upward, and tiny points of newborn light glimmer where fresh stars have only just begun to shine within the eroding gas. It is a scene of slow making and slow unmaking held in one frame, stars being born within the cliffs even as the same starlight wears those cliffs away. The golden eye caught both at once. Sometimes the telescope catches a single star at the very moment of its birth, still buried in the dark cloud that is feeding it. Around one such newborn glows a shape like a soft hourglass of light in the dark. The two glowing cones are light from the hidden star, escaping above and below through the thinner gas, lighting the dust like lamplight shining out through the open ends of a narrow valley. Across the narrow waist of the hourglass lies a dark line, a flat disk of gas and dust, seen edge on, slowly turning around the young star. It is from such a disk that planets are made. Within that turning disk, dust grains are already beginning to stick and gather. In time, some may grow into pebbles, then boulders, then worlds, a new family of planets forming alongside their young sun. So, in a single soft image, the golden eye shows a whole beginning at once, a star kindling, a disk turning, and the first faint promise of worlds, all wrapped together in the dark. A young star is not calm. As it gathers gas and spins faster, it flings twin jets of glowing matter out from its poles, long straight beams shooting into the surrounding cloud in opposite directions. Where those jets slam into the slower gas around them, they light up in soft glowing knots and arcs, marking the path the young star has carved through its cloud like footprints left in deep snow. These glowing trails can stretch for light years on either side of the star, a tally of its restless youth written across the cloud, telling of every burst and pause in its gathering. In infrared, the telescope sees these jets clearly even through the dust, catching the fine structure of the glowing beams where other eyes would see only a dark and featureless cloud. In time, the jets will fade, the star will settle, and the cloud will scatter. But for now, the golden eye holds this brief wild youth in stillness, a newborn sun, shouting light into the dark. Let us rest here, in the nursery of stars among the glowing clouds where new suns are being made. There is something tender about it, the whole vast cosmos busy at the slow work of beginning again. Every star you have ever seen began like this, wrapped in a dark cloud gathering light. Our own sun did too, some 5 billion years ago, in a cloud much like the ones the telescope showed. So these are not strange places, really. They are home places, the kind of nursery your own sun came from, the kind that made the atoms now resting as you rest in your own quiet body. Let the soft glow of the nursery hold you for a while. There is no hurry here. Stars take 1,000,000 years to be born. You only have to take this one slow breath and then the next. Stars do not live forever. A star like our sun shines steadily for billions of years, and then when its inner fuel runs low, it swells and softens and begins the slow glowing close of its long life. Such a star does not burst. It breathes out, layer by layer. It sheds its outer gas into space, casting off glowing shells and rings that drift slowly outward, lit from within by the small hot core left behind. These glowing clouds are called planetary nebulae, a gentle misname from old astronomers who thought their round, soft shapes looked like distant planets. They are not planets at all, but the exhaled breath of a fading star. At the center remains the star's hot core, now a small, dense ember called a white dwarf, no longer burning but still glowing with leftover heat, slowly cooling across the ages to come. It is among the calmest of endings the cosmos offers, not a violent close, but a slow letting go, a star setting down its light into the dark in soft and widening rings. One such fading star gave the telescope a portrait of rare beauty, a soft oval of glowing gas, ring within ring, that we call the southern ring, its shells spread outward like ripples frozen on a dark pond. Looking closely, the golden eye found not one star at the center, but two, circling each other. One is the dying star that breathed out the nebula. The other is a companion that has kept it company all along. The dying star is cloaked now in the dust it has shed, so that in ordinary light it nearly vanishes. But in infrared, the telescope sees straight through the dust to the fading ember within. The shells are not smooth. They are ragged and layered, marking each pulse and pause of the star's long exhaling, a record of its final chapters written in widening rings of gas. It is a quiet monument, this nebula, the visible memory of a star that is letting go, lit softly from within, spreading its last light into the dark for a few thousand years before it fades. Another dying star left behind a near-perfect ring, a glowing circle of gas hanging in the dark like a smoke ring blown by some vast and gentle mouth, with its small hot core resting at the center. Up close, the ring is not smooth, but woven from countless fine threads and knots of denser gas, hundreds of them, like dewdrops strung along a vast and glowing spiderweb. Each of those knots is larger than our whole solar system, and yet from our great distance they soften into the finest of textures, a lacework of light spun by a single dying star. Outside the bright ring lie fainter loops and arcs, older gas cast off long before, spreading the star's slow ending across an even wider reach of the dark. To look at it is to see a kind of clock, each ring and thread marking another stage of the long farewell, a star unspooling its light slowly into a shape of quiet and lasting grace. The largest stars do not fade so gently. When a giant star runs out of fuel, its core gives way all at once, and the star tears itself apart in a single great burst, a supernova brighter for a while than a whole galaxy. Long after the burst, the telescope finds the wreckage still expanding, great glowing shells and curling filaments of gas, the scattered remains of a star spread across light years of dark. In infrared, the golden eye sees the warm dust within the wreckage, glowing fine and feathery, revealing structure too cool and faint for other telescopes to catch in the cooling ruin. It seems a violent thing, and it is, but the same burst that ends the star also forges and scatters heavier elements far and wide, seeding the surrounding dark with the makings of new stars and worlds. So even this, the loudest of endings, is also a beginning. The wreck of one great star becomes the raw stuff of the next generation, and the slow wheel of making turns onward through the dark. Gather up all that the dying stars have scattered, the gentle breath of the small ones, the violent dust of the great ones, and you have the raw material of everything that comes next. That scattered dust drifts through space until it joins a new cold cloud, and in that cloud one day fresh stars will gather and kindle, and around them planets will form from the very same grains. Our own sun and its worlds were built this way from the dust of stars that died before it. The iron in the earth, the gold in its rocks were all forged in stars long gone and scattered here. So the elements that make you were made in stars, scattered by their endings and gathered again into the earth, into the food you eat, into your very bones. You are quite literally gathered stardust. The telescope, looking at the deaths of distant stars, is therefore also looking at our own deep origins, at the slow recycling of matter from which every world and every living thing was eventually made. Let us rest a moment in the soft light of these endings. There is no sadness needed here. A star that fades has shone for billions of years, and even in closing it gives its light and its dust to all that follows. Nothing in the cosmos is truly lost. The gas of an old star becomes the cloud of a new one. The endings and the beginnings are the same slow turning, seen from different sides. It can be a comfort, late at night, to know that the universe wastes nothing, that even its great farewells are also gifts, and that the light of what is gone becomes the substance of what is coming. So let any heaviness ease for now. The stars are not afraid of their endings, and tonight you need not be either. Breathe slow and rest in the soft and lasting light. Turn the golden eye toward a nearby galaxy seen face on, and it reveals a great slow whirlpool of stars, a spiral, its arms winding outward from a bright core, turning so slowly that a single turn takes hundreds of millions of years. In infrared, the telescope traces not the stars alone, but the delicate webbing of gas and dust between them, fine filaments winding along the arms like the veins of a great glowing leaf. The arms are not solid things, but slow waves, places where gas piles up and new stars catch fire, so that each arm glows with the light of countless young suns strung along its curve. Toward the center, the filaments wind tighter and tighter, spiraling down into a small, brilliant core where the oldest, densest crowd of stars gathers around the galaxy's hidden heart. It is a shape that turns up again and again across the cosmos, this slow glowing pinwheel, and the telescope shows it to us in a detail so fine we can follow a single thread of dust from the rim almost to the core. Deep in the core of a great galaxy, the stars crowd together more and more thickly until near the very center they swarm in numbers no night sky on Earth could ever show. And at the exact center of most great galaxies sits something we cannot see directly at all, a black hole of immense weight, millions or billions of times heavier than the Sun, drawing the innermost stars into its slow orbit. A black hole gives off no light of its own. It is a place where weight has grown so great that not even light escapes. We know it only by how it pulls the stars and gas around it into tight, swift circles. When gas falls towards such a black hole, it does not vanish quietly. It heats and glows fiercely as it spirals in, so that the center of the galaxy can blaze with the light of the matter feeding its hidden heart. The golden eye studies this glow, reading the light of the feeding gas to weigh the unseen heart within. It cannot see the black hole itself, but it can read in the swirling light the shape of its vast and silent pull. Galaxies are not still. They drift together over vast ages, and now and then a group of them is caught in a slow embrace, their shapes pulled and stretched as they wheel around one another. The telescope showed one such gathering, a close group of galaxies, several of them locked together by their own weight, trading stars and gas across the gaps between them. Where one galaxy plunges through the group, it drives a great shock wave through the gas. A vast glowing front of heated matter lit up where the galaxies collide, spread across distances light takes ages to cross. These slow collisions are not endings. Galaxies are mostly empty space, and their stars almost never strike one another. Instead, they pass through, mingle, and over long ages may settle together into one larger galaxy. Long curving tails of stars and gas trail behind the meeting galaxies, flung out by the pull, glowing faintly across the dark bridges and streamers marking the slow dance still going on. Step back far enough, and the galaxies themselves arrange into a pattern. They are not scattered evenly through space, but strung along vast threads and sheets with great near-empty hollows between. Along the brightest threads of this web, galaxies gather into clusters of hundreds or thousands, bound together by their shared weight, the densest knots in the great cosmic lacework. Between the threads lie the voids, immense rounded hollows, hundreds of millions of light years across, nearly empty of galaxies, the quiet, dark spaces of the cosmic web. This whole web grew from the faintest ripples in the early universe, tiny unevennesses in that first thin gas, slowly drawn by weight into threads, into clusters, into the great structure we trace today. The telescope helps map this web by finding galaxies near and far and reading their distances, slowly tracing the threads of light that lace the whole visible universe together. Around many large galaxies, the telescope finds faint rivers of stars, long pale streams looping through the dark, the scattered remains of smaller galaxies pulled apart and strung out across the sky. When a small galaxy drifts too close to a large one, the larger one's pull stretches it, draws it out, and slowly unwinds it into a long, thin ribbon of stars wrapped around the greater galaxy. These star streams are faint beyond belief, the ghostly leftovers of galaxies that no longer exist on their own. Only a sensitive eye can trace their pale loops against the deep black. Great galaxies grow this way, in part by gathering up the smaller ones around them over billions of years, swallowing them slowly, knitting their stars into the larger whole. Our own galaxy carries such streams as well, the faint trails of smaller companions it has drawn in over the ages. We live within a galaxy that has been quietly growing in just this way for a very long time. Let us rest now among the great wheeling galaxies, where everything moves so slowly that a single turn outlasts the whole of human history many times over. Nothing here is in any hurry at all. Our own galaxy is turning too, carrying the sun and the earth and your quiet resting body in one slow circle that takes more than 200 million years to complete. Since the last time the sun was in this very spot of its long orbit, the dinosaurs had not yet appeared. That is how slowly the great wheel turns. You're riding it right now and feeling nothing but stillness. So let the great slow turning hold you. You do not have to keep pace with anything tonight. The galaxies will wheel on for billions of years, and you may simply rest, carried gently along with them. For most of history, we knew of only one family of planets, our own, the worlds that circle our sun. Whether other stars had planets too was a question no one could answer, only wonder about. Then, only a few decades ago, the first planet around another sun-like star was found. Since then, thousands more have been discovered, until we now know that planets are not rare at all, but common as grains of sand. There are worlds of every kind out there, great gas giants hugging close to their stars, small rocky worlds, planets of molten rock, planets wrapped in endless cloud, worlds stranger than any in our own quiet neighborhood. But these worlds are unimaginably far, and they shine by no light of their own. Beside the dazzling glare of their stars, a planet is fainter than a firefly beside a lighthouse, almost impossible to see at all. And yet the golden eye can study them, not always by seeing them outright, but by clever, gentle means, reading the planets through the light of the very stars that hide them. Here is one of those gentle means. If a planet's orbit is lined up just right, then once each circle it passes directly in front of its star, and blocks a tiny sliver of the starlight on its way across. From far away, we cannot see the planet itself, but we can measure that small dimming of the star, a slight, regular fading and brightening, repeating each time the world comes round again. From the depth of that dimming, we learn the planet's size. From its rhythm, the shape and speed of its orbit, a faint repeating shadow becomes a whole world's measure taken across the light years. It is a faint signal. The dimming may be less than a single part in 100, or far less, so the telescope must hold its gaze with great steadiness, watching one star for hours as the world crosses. And in that crossing lies a deeper secret still. For as the planet passes, a thin sliver of starlight grazes the very edge of the world, through its air, if it has any, and carries away the story of what that air is made of. As a world crosses its star, a little of the starlight does not pass beside it, but through the thin ring of air around its edge. That air leaves its mark on the light, faint as breath on cold glass. Different gases each absorb their own particular shades of light, so by reading exactly which shades are missing from the starlight that came through the air, the telescope can name the gases in a world it will never visit. It is an astonishing thing to sit with, that we can stand on one small world and learn the air of another, trillions of kilometers away, just by watching its star wink behind it. The signal is faint beyond measure. The air of a far world dims the starlight by less than a breath. Only an eye as large and steady and cold as this one could ever read it cleanly. And so a planet stops being a mere dark dot and becomes a place with weather, with chemistry, with an atmosphere that the golden eye can quietly read from across the gulf of the stars. One of the first far worlds the telescope studied this way was a great hot gas giant, circling close to its star, and in the thin starlight that passed through its air, the golden eye found the clear mark of water. Not oceans on so hot a world, but water as vapor, as steam, woven through the burning air of a planet far too hot for any sea. Even there in that furnace, the simplest of familiar things was present. On another such world, the telescope found the mark of the gas we breathe out, carbon dioxide, the first time it had ever been clearly read in the air of a planet beyond our own. And it found signs of a slow chemistry at work in that air, the starlight itself reshaping the gases over time, the same kind of light-driven change that shapes the high air of our own world. Each of these readings is small in itself, but together they open a door. We are beginning gently to take the weather reports of other worlds, to learn the skies of planets we will never reach. Some of the worlds the telescope studies are stranger than any tale. There are planets where the clouds are not made of water but of rock, fine grains of mineral, lofted as sand clouds high in a scorching sky. On such worlds, it may rain glass or molten rock, blown sideways by winds far fiercer than any storm on Earth, in skies that glow with the heat of a star held terribly close. There are worlds tide-locked to their stars, one face in endless blazing day, the other in endless frozen night, with a narrow ring of softer light forever between them. By reading the changing light through a long orbit, the telescope can even begin to map the heat across such a world where its air is hottest, how its winds carry warmth from the day side toward the night. These are places we will never stand upon, and could not survive if we did, and yet through the careful reading of light, they become known to us strange far worlds, each with weather all its own. Among the thousands of far worlds, a few draw the eye more than the rest, small rocky planets near the size of our own, circling their stars at just the distance where water might rest as liquid on the ground. There is one small cool star nearby that carries a whole family of such rocky worlds, several of them about the size of the Earth, a few at the right distance for water to perhaps remain unfrozen. The telescope is now studying these worlds one by one, asking the first careful question, do they hold any air at all? For without an atmosphere, even a world at the right distance would be a bare and airless stone. It is slow and difficult work, reading the thin signals of small rocky worlds, far harder than reading the great gas giants. The answers come gradually, one careful observation at a time. We do not yet know whether any of them could hold life, and we may not know for a long while, but for the first time, the question is no longer only a dream. It has become something a telescope can begin gently to ask. Let us rest a while beneath these other suns, among the far worlds we will never visit. There is a soft comfort in their distance. They ask nothing of you, and yet they are there, real and turning, beneath stars of their own. On some far world tonight, a strange sun may be setting over an unknown horizon, its light passing, at this very moment, through an air no one has ever breathed. You will never walk there, and that is all right. It is enough to know the worlds are real, that the night sky is not a ceiling of lights, but a depth full of places, each with its own quiet weather and its own slow days. So let your thoughts wander among them lightly, the way you might wander a far shore in a dream. Then let even that go, and sink gently toward sleep beneath the soft light of all those distant suns. The golden eye does not look only to the far reaches. It turns too toward our own neighborhood, toward the planets that circle our own sun, and the largest of them is the great banded giant we call Jupiter. Jupiter is a world without solid ground, a great ball of gas and cloud wide enough to swallow more than 1,000 Earths, wrapped in stripes of cloud that race around it in opposing winds. In its southern half turns a storm older than any on Earth, a vast spinning oval wide enough to swallow our whole world that has been turning for centuries without stopping. In infrared, the telescope shows Jupiter in new tones, the high hazes glowing where sunlight catches them, the deeper clouds darker, the whole giant rendered soft and strange and beautiful. And around the giant, the telescope finds its faint companions, thin, dusty rings easy to miss, and the bright points of its larger moons, a small system turning in the giant's reflected light. At the top and bottom of Jupiter, where unseen lines of force gather, the telescope reveals great curtains of glowing light, auroras like our own northern lights, but vaster and far more fierce. These auroras are larger than the entire Earth, ringing each pole of the giant in light that never quite goes out, fed by the endless rain of particles caught in the giant's vast field of force. The same hidden force that lights the auroras also catches particles flung from Jupiter's volcanic moon, feeding the glow with matter thrown off by a small world circling close. To see all this at once, the racing bands, the ancient storm, the thin rings, the moons, the glowing polar crowns, is to see Jupiter not as a dot in a backyard telescope, but as the vast living system it truly is. And it is close enough in cosmic terms that the telescope can watch it change from week to week, the storms shifting, the hazes moving, a giant world breathing slowly just next door. Far beyond Jupiter circles a smaller giant, a deep blue world so distant that sunlight there is dim, and a single one of its years lasts longer than a human lifetime many times over. When the telescope turned toward this far blue giant, it caught something not clearly seen in over 30 years, the planet's faint rings, complete and delicate, glowing softly all the way around. In the infrared, the blue world does not look blue at all, but pale and pearly, its high hazes catching the dim sunlight, a few bright clouds glowing where storms rise in its cold sky. Around it, the telescope found the bright points of its moons, among them a large one that circles backward, thought to be a captured wanderer from the cold outer dark, now bound to the giant forever. It is a world at the cold edge of the sun's family, dim and distant and slow, and yet the golden eye brings it close and shows its quiet rings glowing softly in the dark. Between and beyond the planets drift the small bodies of the sun's family, the rocky asteroids, the icy comets, countless lesser worlds too small to be planets, yet each a place in its own right. The comets are the icy ones, born in the cold outer dark. When one wanders close to the sun, its ice warms and turns to vapor, and it grows a soft, glowing head and a long tail streaming away from the sun. The telescope has read the vapor rising from such comets and found among it the clear mark of water, the same water that fills our seas, carried frozen in small icy bodies for billions of years. Some believe that comets and watery asteroids falling long ago onto a young and barren Earth may have brought much of the water that became our oceans. If so, the seas began as ice among the stars. So even the smallest wanderers carry a story. By reading their ice and dust, the telescope helps trace where the Earth's own water came from and how the makings of a living world were scattered through the sun's family. Let us rest near home now, among the familiar planets of our own sun. After all the distant galaxies, there is a quiet ease in coming back to this small bright neighborhood, the one our Earth belongs to. These are the worlds that have shared our sky since before there were people to name them. The bright wanderers our ancestors watched move slowly among the fixed stars, night after night. And here, third from the sun, is our own small world, the only one so far as we know, where anyone is lying down tonight to rest beneath this same slow sky. So let yourself settle back onto it, this turning blue world that carries you. You are held by its weight, warmed by its air, carried through the dark among its sibling planets. You are home and you can rest. Here is one of the strangest truths the sky has taught us. Nearly every distant galaxy is moving away from us, and the farther it lies, the faster it recedes, as though the whole cosmos were quietly growing. It is not that the galaxies are flying through space away from some center. It is space itself that is stretching, swelling between the galaxies, carrying them apart the way dots on a rising loaf of bread drift away from each other as it bakes. We read this growth in the light of the galaxies. As space stretches, the light crossing it stretches too, sliding toward the red, and the farther the light has come, the more its color has shifted. Run that growth backward in the mind, and everything draws together, the galaxies, the gas, all of it, toward a single hot, dense beginning long ago, from which the whole expansion has been unfolding ever since. The telescope, by measuring the light of far galaxies with great care, helps us read how fast the cosmos grows, and how that growth has changed across the long unfolding of time. There is a gentle puzzle here, one the telescope is helping to study. When we measure how fast the cosmos grows in two different ways, the two answers do not quite agree. One way reads the growth from the faint glow left over from the early universe. The other measures it from certain nearby stars and galaxies whose true brightness we believe we know. The two numbers come out slightly apart. It is a small gap, but a stubborn one, and it will not go away. Either there is some quiet flaw in how we measure, or there is something about the cosmos itself that we do not yet understand. The golden eye helps by measuring those special marker stars more sharply than ever before, checking whether the gap is real or only a trick of the older, blurrier measurements. So far, the gap holds, and that is its own kind of thrill, a hint that the universe still keeps a secret or two, waiting at the edge of what our best instruments can measure. The space between the stars is not truly empty. It is thinly filled with gas and dust, and woven through that dust are molecules, not just simple gases, but large rings and chains of carbon, the same element that forms the backbone of all life. The telescope finds the soft glow of these carbon molecules across the dusty clouds of our galaxy, and even in galaxies far away, shining faintly wherever starlight warms the drifting dust. These are the soot and smoke of the cosmos, in a sense, the same kinds of carbon rings found in candle flames and old campfires, scattered freely through the great clouds where stars and planets are made. That matters, because carbon is the steady builder of complex things. Wherever it gathers, richer chemistry becomes possible, and the simple makings of life have a place to begin. So the dust the old telescope saw only as a nuisance, blocking the view, turns out to be a quiet storehouse, full of the very molecules from which living worlds may one day be built. Look into the disks of gas and dust that circle newborn stars, and the telescope finds them rich with the simple ingredients of life, water and carbon molecules and more, already gathered there before the planets have even formed. Water especially seems to be everywhere, frozen onto dust grains in the cold clouds, carried into the disks, ready to be built into comets and worlds, just as it was in our own young solar system. In some young disks, the golden eye reads the warm vapor of water rising near the star, and the marks of carbon molecules further out, a whole pantry of ingredients laid out where new planets will gather them. None of this is life itself. It is only the raw stock, the water, the carbon, the simple molecules, but it is the same stock from which life arose on Earth, and it appears to be common across the galaxy. So the makings of living worlds are not rare or precious things, hoarded in one corner of the cosmos. They are scattered everywhere. Stars are born, a quiet abundance, waiting in the dark. And so we come to the oldest question of all, the one that hides behind every other. In all this vastness, among all these worlds, are we alone? Is there anyone else out there looking back? The telescope was not built mainly to answer it, and it likely cannot, not on its own. But for the first time, it lets us begin to look in the right way by reading the air of small far worlds for the marks of life. For life, if it is there, may leave a trace in the air, certain gases together that ought not to last unless something keeps renewing them, the faint chemical breath of a living world. Reading such faint marks on so small and far a world is at the very edge of what is possible, and may take many years and many careful looks, and perhaps telescopes yet to come. There is no hurry in it. But the question is no longer only a dream whispered at the night sky. It has become gently a thing we can begin to study, one faint world, one careful reading of light at a time. Let us rest a while with the great questions, and let them be soft rather than heavy. You do not have to answer them tonight. No one does. They are the kind of questions meant to be lived alongside, not solved before sleep. Whether we are alone or not, the cosmos is full of water and carbon and the makings of worlds. That much we now know. The dark is not barren, it is rich with the same stuff that became you. There is comfort in that, in being made of common cosmic stuff, in belonging to a universe that builds water and carbon and stars wherever it can. You are not a stranger here, you are made of the place itself. So let the questions rest now unanswered and at ease, and let yourself rest with them. The cosmos has waited billions of years for its answers. It can wait kindly while you fall asleep. Out beyond the great storms of the giants circles a stranger world, a cool blue-green giant that does not spin upright like the others, but lies tipped fully onto its side, rolling around the sun like a ball set, rolling along the ground. Because it lies on its side, its seasons are unlike any other world's. Each pole in turn points almost straight at the distant sun, bathed in a single long stretch of daylight that lasts for many of our years before the long darkness comes. When the golden eye turned toward it, the world that other telescopes show as a featureless ball revealed soft bands, a bright glowing cap of high cloud over its sunward pole, and the faint structure of its restless upper air. And around it the telescope caught a wonder rarely seen, the planet's faint rings, thin and delicate, including a dim inner ring so elusive that only the sharpest eyes have ever found it. Several of its small moons glimmered nearby, points of light circling the tipped world, a quiet little system rolling sideways through the cold outer dark, brought close and clear by the golden eye. No world is lovelier in a small telescope than the great ringed giant, its broad bright rings circling it like a halo. It has charmed every eye that has ever found it in the evening sky. But in infrared, the golden eye shows it transformed. The planet itself goes dark and soft, its gases drinking in the infrared light, while the rings blaze bright around it, glowing where the planet has dimmed. The rings are not solid bands, but countless small pieces of ice and rock, from grains to boulders, each on its own small orbit, all circling together into the appearance of smooth, bright hoops. Around the darkened planet, several of its moons shone clear, bright points strung near the glowing rings, each a frozen world of its own, circling the giant in the cold. It is a familiar wonder made fresh and new, the most beloved planet in the sky, shown not as the eye knows it, but as the warmth of infrared reveals it, glowing softly in the deep. One of the ringed giant's moons is a world unto itself, larger than the smallest planet, and the only moon in the sun's family wrapped in a thick and hazy air, a soft orange veil that hides its surface from ordinary view. Beneath that haze, this strange moon has weather. It has clouds that gather and move, and rain that falls, though not rain of water, for it is far too cold, but rain of cold liquid methane, the stuff of natural gas. And on its surface lie seas, broad dark lakes and seas of liquid methane and its kin, lying in the frozen lowlands fed by rivers and rain under a thick golden sky. When the golden eye looked through the haze, it tracked the clouds moving across the moon's sky, watching its slow weather shift from day to day, the only other world we know with rain falling onto open seas. It is, in its strange, cold way, the most Earth-like surface in the sun's family, a place of clouds and rain and shorelines, though built of frozen gases under a dim and distant sun. Another of the giant's moons is small and white, and wrapped in clean bright ice, a frozen pearl no wider than a small country, circling far out among the rings. Beneath its icy shell lies a hidden ocean of liquid water, kept from freezing by the slow flexing of the moon as it circles the giant, a warm sea sealed under a frozen sky. From cracks near its southern pole, that hidden ocean escapes, great fountains of water vapor and ice jetting out into space, rising in soft plumes far above the little moon. When the golden eye looked, it found a plume larger than anyone had imagined, a vast soft jet of water reaching out many times the width of the little moon, feeding a faint ring of vapor all around the giant. In that escaping water may be carried the makings of life, the salts and simple molecules of a hidden sea, sprayed into space where a passing telescope can read them from a warm ocean we may never reach. Let us rest a while among the moons of the giants, these small frozen worlds with their hidden seas and their soft falling rain. There are dozens of them, each quiet and strange, circling slowly in the cold. It is restful to think that even now on a moon a billion kilometers away, soft methane rain may be falling onto a still dark sea, with no one there to hear it, only the slow weather of a cold and distant world. And beneath the ice of another small moon, a hidden ocean stirs in the deep, dark, warm and salty and still, going about its slow tides without sun or sky, sealed away for ages. There is a soft company in these distant places. The cosmos is full of quiet worlds, each turning through its own slow night. You are one quiet world among many tonight, and you may turn just as softly toward sleep. Far beyond our own galaxy lies a vast star-forming cloud, the largest and brightest in all our neighborhood of galaxies, a single great nursery where many thousands of stars are being born at once. At its heart blazes a tight cluster of enormous young stars, some of the most massive known, pouring out fierce light that carves great glowing caverns in the surrounding gas. Their light and wind blow the gas back into soft pillars and ridges and arching walls, a vast sculpted landscape of glowing cloud, light years deep, lit from within by the newborn sun. When the golden eye looked into this great cloud, it found, behind the bright young giants, tens of thousands of fainter young stars never seen before, a whole hidden multitude packed into the glowing gas. It is a single image holding more newborn stars than all the stars you could ever see on the darkest night from Earth, a whole generation of suns caught together in the moment of their birth. Now and then the golden eye finds a rare star caught in a brief and dramatic phase, a massive star in the last stage before its end, casting off its outer layers into space in great glowing veils. Such a star burns so fiercely that its own light tears its outer gas away, flinging it outward in soft expanding shells and streamers, slowly stripping the star down toward its final violent close. In infrared, the cast-off shells glow soft and intricate, lit by the doomed star at their center, a brief flower of gas and dust that will last only a short while before the star is gone. These shells carry the heavier elements the star has made, scattering them into the surrounding dark, seeding the next generation of stars and worlds, even as this one approaches its end. To catch such a star is rare, for this phase is brief by cosmic measure. The golden eye holds it still for us, a great star in the soft glow of its final shedding, beautiful at the edge of its end. Sometimes a distant galaxy lies almost exactly behind a nearer one, and the nearer galaxy's weight bends the far one's light into a smooth, near-complete ring, a perfect circle of light around a glowing core. The ring is not a real object, but an image, the light of a single far galaxy, smeared by gravity into a full circle, wrapped neatly around the galaxy whose weight is bending it. Such rings are rare and lovely, and useful too. From the size and shape of the ring, those who study the sky can weigh the unseen matter in the foreground galaxy, including the dark invisible stuff that holds galaxies together. And the ring also magnifies the far galaxy, letting the telescope study a distant thing made larger and brighter by the lens of gravity, a far galaxy brought close by a trick of bent light. It is one of the quiet marvels of the cosmos that weight bends light, that a galaxy can act as a lens, and that now and then the alignment is so true the bent light closes into a ring of soft fire. The golden eye has caught pairs of galaxies in the long, slow dance of meeting, one drawn out by the other's weight into a sweeping curved shape, the two of them reaching toward one another across the dark. Where the galaxies pull at each other, fresh waves of starbirth light up along their stretched arms, glowing knots of new stars strung where the gas has been squeezed by the meeting. Between them stretch faint bridges of stars and gas, drawn out across the gap by gravity, soft threads of light linking the two galaxies as they slowly wheel together. Over hundreds of millions of years, such pairs will swing around each other again and again, mingling their stars until at last they settle together into a single larger galaxy, calm once more. What the telescope shows is a single still frame of that vast, slow dance, a moment held from a motion so slow that, to us, the two galaxies seem frozen forever in their reaching. Within the great clusters of galaxies, the golden eye finds a faint and ghostly light spread between the galaxies themselves, a soft glow filling the spaces, dimmer than almost anything else the telescope reads. This glow comes from countless lone stars, torn from their home galaxies long ago by the pull of the cluster, now adrift between the galaxies belonging to none of them, lighting the gaps with their scattered glow. These wandering stars trace the long history of the cluster. Every collision, every galaxy pulled apart, has left its stars scattered into this faint shared light, a soft record of ancient upheavals. To see such a faint glow at all, against the dark and beside the bright galaxies, takes an eye of rare sensitivity, able to gather the dimmest scattered light without losing it in the glare of its brighter neighbors. So even the empty seeming spaces between galaxies are not truly dark. They hold their own soft light, the glow of wandering stars found by a telescope keen enough to read the faintest shine in the deep. With every season, the golden eye reaches a little further and a little finer into deeper fields, fainter galaxies, smaller worlds, and the dimmer, colder corners of the sky that older eyes could never reach. Each new look builds on the last. A galaxy found one year is studied more closely the next. A faint world glimpsed once is watched again and again, until its story slowly comes clear across many careful gazes. There is no single great discovery that finishes such an eye's work. There is only the long, steady gathering of seeing, fact upon fact, image upon image, slowly deepening what we know of the cosmos. And much of what it will find is surely still unguessed. Wonders we have no names for yet, waiting in the deep fields and the dusty clouds and the air of far worlds for the golden eye to turn their way. So the looking goes on, and the universe keeps opening a little wider each year before the steady gaze of the great cold mirror at its far and quiet station in the deep. Out at its far station, the telescope keeps a watch that never stops. There is no day or night there, no weather, no season, only the steady dark and the slow turning of its gaze from one patch of sky to the next. Its hours are filled by careful plans made far below. One after another, the targets come. A far galaxy, a forming star, a passing world, each given its measured share of the great mirror's time. When it has gathered the light it was sent to gather, it turns gently and sends the day's findings homeward, a faint signal crossing 1.5 million kilometers of dark to waiting listeners on the earth. Then it turns again to the next target and the next. There is no rush in any of it. The work is measured out in long, calm hours, and the mirror gives each one its full and undivided gaze. And so the watch goes on, hour after hour, far beyond the moon, while the world that built it turns through its days and nights, mostly unaware of the quiet-looking happening so far overhead. Think of it as you lie here right now. In this very hour, the great mirror is open somewhere far above, gathering the faint light of some distant thing, grain by grain, while cities sleep and lamps go out. The telescope keeps working untouched by the rhythm of our days. The light it gathers tonight began its journey long before there was anyone here to sleep at all. Somewhere, A photon that left a galaxy 13 billion years ago is settling onto the golden mirror at this moment, ending its long crossing in a soft tally of ancient light, while you breathe slowly in the dark. There is something restful in that the looking does not need you to be awake. The work of seeing the universe carries on gently through the night, asking nothing of you but that you let it. So you may let go of any watching of your own. The great eye has it covered. You can close your eyes here while it keeps its open far above, gathering the light of the deep past until morning. The telescope was set on its way so cleanly, with such a careful launch, that it spent far less of its fuel reaching its station than anyone had dared to plan for. The saving was a quiet gift. That small grace means it can keep its station and keep looking for around 20 years, far longer than first hoped, 2 full decades of gathering light from the deep past and the far worlds. 20 years is a long human time. A child born the night it launched will be nearly grown before its work is done, and in all those years it will gather more of the universe than we can yet imagine. It will study things not yet discovered, answer questions not yet asked, and very likely surprise us again and again, as the deepest instruments always do. Most of its story is still ahead. When at last its fuel runs low and it can no longer hold its station, it will go softly quiet and keep its long, slow loop around that far point, a small golden monument to a long-looking, circling on in the dark. In only its first short while of looking, the telescope has already changed parts of the story we tell about the cosmos, found galaxies older and brighter than expected, read the air of far worlds, and seen the birth of stars in new detail. It has pushed the edge of the visible further back toward the beginning, finding light from galaxies that formed when the cosmos was younger than anyone had ever managed to see before. It has found water and carbon and the makings of worlds scattered through the dust, read the weather of planets trillions of kilometers away, and shown the rings of a far giant unseen for a generation. And it has done all this in just the opening years of a watch meant to last 2 decades. The textbooks are already being gently rewritten, chapter by chapter, image by image. Whatever else it finds in the long years ahead, it has already given us a deeper, wider, older universe than the one we knew before, and it is only just beginning to look. For all its size, the telescope is a small thing against the cosmos it studies, a mirror you could measure in paces, set against galaxies measured in light years, looking out at a universe with no edge that we have ever found. And we who built it are smaller still, brief, soft creatures on one small world, gazing out across distances and ages our minds can barely hold, and yet we built an eye to see them and learned slowly to read their light. There is no shame in being small beneath such a sky. To be small and curious, and to look anyway, may be among the finest things a brief creature on a small world can do. The vastness need not frighten you late at night. It can hold you instead, a wide, calm, ancient place, far older and far larger than any trouble, with room enough in it for every worry to grow small. So let the great sky be a comfort, not a weight. You are a small part of something immense and old and quietly beautiful, and tonight you can simply rest within it, held by its vast and gentle dark. Of all the things the telescope gathers, The strangest to sit with is this: the oldest light it sees set out near the beginning of the universe and is only arriving now, tonight, after 13 billion years of travel. All through the forming of the galaxies, the birth and death of countless stars, the making of the earth and the long story of life upon it, that light was already on its way, crossing the dark toward this moment. It passed through the clearing of the cosmic fog, through the growing web of galaxies, through all the ages it took for a world like ours to appear, and it is landing on the golden mirror only now, while you lie here in the dark. When you look at one of the telescope's deepest images, you are not seeing the past in a picture. You are seeing the actual ancient light itself, caught at the end of its long crossing, as real as the lamp beside your bed. There is a quiet wonder in that, large enough to grow sleepy inside of that. The beginning of the universe is still arriving softly every night onto a small golden mirror far above your resting head. We are, each of us, made of the stuff the telescope studies, the hydrogen from the beginning, the carbon and oxygen and iron forged in stars gathered over billions of years into a world and then into a living resting body. The same kinds of clouds the golden eye watches making stars once made our sun, the same kind of dusty disk it sees around far young stars once made the earth. The story it tells is, in the end, our own story too. So when the telescope looks back toward the first light, it is looking back toward where we came from, tracing the long road from the first glow of the cosmos to a small warm world where someone lies down, at last to sleep. You are the universe's own late chapter, a place where the cosmos has gathered itself together briefly and learned to look back at its own beginning with wonder. That is no small thing, however small you feel. And tonight, that is enough. You do not have to understand it all. You only have to rest here, a small warm part of a vast old story, beneath the first light that is still even now arriving. Let us rest here at the close beneath the first light of the universe. The journey is nearly done now, and there is nothing left to do but let go and let the soft dark gather around you. Far above, the golden eye keeps its watch, gathering light it will never need you to see. The galaxies turn, the far worlds circle their suns, none of it asks anything of you tonight. Let your breath grow slow and even, like the slow gathering of light on a cold mirror. Let your thoughts settle the way dust settles into the disk where worlds are made. There is all the time there is. You are held tonight by a turning world, beneath a vast old sky, within a cosmos that built you from its own ancient light. You are exactly where you belong. You can rest now and let sleep take you. We have come a long way tonight, out past the earth and the moon to a golden eye in the dark, and then far beyond it, to the birth and death of stars, the wheeling of galaxies, the worlds of other suns, and the first light of the cosmos itself. Thank you for spending this night with the Circadian Institute. If this slow journey through the deep sky helped you toward sleep, subscribing is the kindest way to keep these long, calm nights coming, week after week, always meant for rest. Far above you, the great mirror is still gathering light, and it will go on gathering it long after you have fallen asleep. The galaxies will keep turning. The ancient light will keep arriving. None of it needs your watching now. So let yourself rest now. Sleep deeply and sleep well. The first light of the universe is still on its way, and it will still be arriving when you wake. There is nothing more to do tonight. Good night from the Circadian Institute.